I'm going to take, this is actually interesting. So the vector itself, if you look here, it's 30.4 to the right and 23.3 down. So it'd be 30.4 to the right, okay, and 23.3 down. So the actual vector itself is probably only like this long. Because you had all this x, but then you subtracted a bunch of x, and then you added some back. So we can see why it's not fully there. And then you had a little bit of down y here, a little bit of x here, so you have more positive here than here, and this drags it down, so that's there. So if we're going to get the angle, let's get this angle right here. So we're going to do the opposite, which is 23.3 divided by 30.4. Take the inverse tangent, and the angle is 37.5 degrees. So it's 37.5 degrees. Now, that's negative 37.5 degrees measured from the positive x-axis. So, like that. Okay, let's look at 23. Problem 23 says, if b is added to c, which is given, the result is vector in the positive with a magnitude equal to c. What is the magnitude of b? Ugh. Okay, so it gives us this. It says that the vector c is 3i plus 4j. That's the first thing it tells us. No problem. And then it says that I'm going to add some b vector, which I don't know the components. We're going to have to figure that out, such that b plus c has 0 in the I direction, plus, now what does it have in the j direction? It says in the j direction, the magnitude is equal to the magnitude of c. Okay, well, what is the magnitude of c? Well, let's look at the c vector. If the c vector is 3 to the right and 4 up, what's the magnitude of the c vector? Well, the c vector must be 5 long. So the c vector magnitude is 5, and then b plus c is only in the y direction with magnitude equal to that of c. So this is 5j. The hardest part of this is figuring out the wording. So then it says, what is the magnitude of b? All right, well. So now I know that b plus c is equal to 0i plus 5j. But b plus c is equal to, basically, it's b in the x direction plus c in the x direction plus b in the y direction plus c in the y direction. So when I know these, right, I don't know my b in the x direction, but I know my c in the x direction was 3. I don't know my b in the y direction, but I know my c in the y direction was 4. So that means if I know that b plus c is equal to 0 plus 5j, and I know that this and this is also b plus c, then basically I can say that I'm going to compare these here. So I can say that 0 is equal to bx plus 3. And I can say that 5 is equal to bx plus 4. So what does that mean? That means that b in the x direction is equal to negative 3. Oh, there's a typo here. And that the b in the y direction is equal to 1. So that seems all right. And so what is my b vector then? So I'm going to write my b vector. It's going to be equal to negative 3i plus 1j. And what's cool about this is if I now add b and c together, so I put my c vector underneath it, well, you notice if you add these up, just b plus c, this goes to 0 and this goes to 5, and that's how I get the b plus c. So that seems good. So if I want to get the magnitude of the b vector, this is the square root of 10. Okay, so that's the square root of 10 there. Does it ask for an angle on this one? Nope, it just asks for the magnitude. So I think that's 3.16 or something like that. Okay?
Any garbages?
Not
No.
if you've got it yesterday.
Okey doke, yeah, I did. Okay, thanks.
Thank you.
Yep.
So in this one, this is P31. In P31, it says the figure gives you an xy coordinate plane, and then it draws a vector for you. Okay? Now, then it does something weird. So this is the x coordinate, or the x axis and the y axis, and there's my vector. Okay? Then it says, what would happen if you rotated the axis? Because this xy is arbitrary. We like it because it's parallel and perpendicular to the board, but you could use any axis that you wanted. So what would happen if you rotated it? Okay? So right here, if I drop this down, this distance from here to here is, oh, this vector is A. That vector is A. So that this right here would be the A x component. That distance would be the A component. And then this distance here, up here, that would be the A y component. Okay? So if you wanted to get the components, I'm going the wrong direction here. If you wanted to get the components, you could just do it straight away, right? So you would have to know the angle, and it tells us that this angle here is 56 degrees. Okay? And it tells me the length of A is 17. So this is 17. All right, so the same thing we've done before. AX is equal to, well, it's going to be then 17 cosine 56. So that's 9.5. And then AY is gonna be equal to 17 sine 56. So AY is equal to 14.1. All right. Fantastic. But then it says, what I'm gonna do is I'm gonna rotate this whole thing. Okay, it says I'm gonna rotate it so that I think it rotated, it tells me here. I'm gonna rotate it 18 degrees. So I'm gonna take the whole thing and rotate it 18 degrees. So to do that, we're gonna get a new coordinate plane here. That was a little janky. So we call this call this one x prime, and this one is y prime. But what you'll notice here is that we could still break it up into its horizontal and vertical components, where that's 90, that's 90. Oh God, that was ugly. It's challenging my ability to draw this here. Okay, that's much better. And then it wants to know what these components are. So now we can see that this one got longer, but this one got a lot shorter. So if this down here is 18 degrees, then the angle we're actually interested in is this one here. So 56 minus 18 is 38. So now we can just work it out. We can say that a prime x is equal to 17 times the cosine of 38. So a prime x is equal to 13.4. And a prime y is equal to 17 times the sine of 38 degrees. So a prime y is equal to 10.5. So the hard part of this was realizing you shifted it 18 degrees, so that left you a new angle to work with. And we'll notice that if you look at the x components, the x got bigger. Here it was ax, here it's a prime x is much bigger, but the y got smaller. This is ay here, and this is a prime y, and you can see it got smaller. But the thing that's really cool is after you do the components, if you take the Pythagorean theorem of these two, 13 squared, 13.4 squared and 10.5 squared, and you got the magnitude there, and then you took the Pythagorean theorem of these two here, 9.5 squared and 14.1 squared, they would give you the same value, which is your 17. So that's what's cool about this. You can take your coordinate plane and you can change it, and it doesn't change your vectors.